Number 10 says 10 students are competing in a math competition in which the top 3 will be awarded a prize. How many different ways can the students place as first, second, and third place? You will definitely have a problem on your ACT Aspire similar to this, and this is not a standard in either Algebra 1 or Geometry. It's more of a statistics problem. But I want you to be able to be successful on this because your calculator can do this problem for you. So this one would be really hard to do by hand because it's a really high number. Since you're given 10 students, if you numbered out your 10 students and you try to place them in the first, second, and third place, you would run out of room on your paper. There's just no way, because even if you take these 3 students right here, the first person could be first place, the first person could be second place, the first person could be third place, right? This number 2 person could be first place, right? The third place could be third place or second place here, and we're still not exhausted in those situations, and all we were doing is just looking for those first 3. So imagine if you were doing that for all 10 students. You would just go crazy trying to get all the different options out. So there are two terms here that we need to know, and they are combinations and permutations. Most of the time when we use the word combination, we're really not using it correctly. For example, you call your locker a combination lock, and it's really not a combination lock, because combinations are when order does not matter. Permutations are when order does matter. And when you're putting your 3 numbers on your locker, you have to put the 3 numbers in the right order. So your order does matter. So your locker is really a permutation lock because you have to put those 3 numbers in a particular order for it to work. Well, in this case, first, second, and third, the order matters. We're not just saying how many different places can they be in the top 3. We're saying specifically that this is a different outcome than this right here. Those are totally different. Even though it's the same 3 students, they're in a different order. So this is a permutation problem. So on your calculator, if you will go to the math button, so math is right here underneath the green alpha button, and this is a probability problem, and so you have different headers up here. We want this one that says prob at the top. Combinations and permutations are number 2 and 3 on this part of our calculator. Now notice it says NPR, that's for permutations, and NCR is for a combination. So we're obviously going to be using number 2, which is NPR, but we have to know what these numbers represent. We have to put them in the right order. This is the number you are choosing from, and this is the number you are choosing. So we have 10 students that are competing, so our N value is going to be 10. We're not picking all 10 students though. We only want first, second, and third place, so the number we're choosing is a 3. So this is what we want to put in our calculator, but there's a little trick to putting it in there. You can't just go straight here and go to number 2. You're going to have to go back to your original screen first, and you have to type in your N value first. So I'm just going to type in 10 on my blank screen. Then I'm going to go to math, scroll over to probability, go to number 2, which is NPR, and do you see how that 10 became my N value? And now I just need to put in my R value, which is 3. And now my calculator does the formula for me, and it tells me there's 720 different ways that could happen. So that's why this is not a good way of doing this on your ACT Aspire. You just would not have enough time to come up with 720 different possibilities. So again, that's called a permutation when the order does matter, combination when it does not. So if we just wanted to know how many different ways could the students be in the top 3, we don't care if it's first, second, or third, all of these would be the same outcome because that's these 3 players that are in the top 3. Then we would do 10C3. And so we can see what that would be. Type in 10. Go to math, go over to probability. We want number 3 this time, and we put in our same number. We want just the top 3. You can see there's a whole lot less options, 120 ways. Because again, this would all be the same way. Those aren't separate ways if the order doesn't matter. So always think to yourself, one way to remember it, if you order a combination meal, it doesn't matter what order they give it to you in or what you eat it in. You can eat it in any order. But if you go to the hair salon to get a perm, those steps have to be done in order or you will not get the results that you want. So maybe that'll help you remember. Combinations when order does not matter. Permutation is when it does.